When I did a comparison of the airflow for this shop vac versus this blower on the back of my router table, the shop vac's airflow was less than half as much. It's less than I thought it would be, and I figured maybe it's the hose. So I've got my shop vac with a standard hose on it to a box with an opening 12 centimeters in diameter, and then I can measure the airflow by measuring the airspeed into it. So we got 2.2 meters per second, and 2.2 meters per second works out to 52 CFM. Now with the blue hose that I normally use, which is a fair bit longer but also a little bit wider. Let's call that 2.9. So even though this hose is longer, I get a bit more airflow through it. And that's because this hose is a fair bit thicker. It's actually a pool hose. Let's try this 2.5 inch dust collector hose, which unfortunately doesn't quite fit on here, but I made an adapter. And that increased the airflow once again. Let's try it with no hose. 91 CFM, so the standard hose nearly cuts the airflow in half. Since my 2.5 inch hose did so well, I've now got all my 2.5 inch hoses hooked up 30 feet. So as it turns out, those 3 hoses together still have less air resistance than this one hose here. I get 64 CFM versus 52 CFM with a standard hose. And I know some people like long wind-up hoses with a shop vac. I don't have one of those, but here it is with a central vac hose, which is about the same length, a wee bit longer than my 2.5 inch hose I just tested with. And with that hose, I get the smallest amount of all, less than a standard hose, and just over half of what I get with the same length of 2.5 inch hose. Okay, now let's test that against a cheap 1 horsepower dust collector. That's about 320 CFM. And with a 2.5 inch hose. And now with a long central vac hose. And my airflow is so low, this thing doesn't even give me a reading. So what's interesting is, with a 2.5 inch hose, I had 81 CFM with the shop vac, 91 with the dust collector, but as soon as I went to a 20 foot hose, I went from 74 here to 57 here. So with a longer hose, the vacuum cleaner did better. And that's because even though this can do way more CFM, it has less pressure on there. So we can see here, this dust collector gives us about 18 centimeters worth of suction. Now I know the shop vac would just suck all that water straight out, so I have to change my arrangement a bit. So I hooked up the small hose to the shop vac hose and up and down into this container, and I'm getting about 107 centimeters of suction. That's almost 6 times what this one can do. And that's why a shop vac is able to deal with these narrow hoses, even long ones. But of course, it does benefit from having a bigger hose, whereas this can deliver a huge amount of CFM, but not through a small hose. And for comparison, I just tested it with my homemade dust collector, and it delivers more CFM than the shop vac, and more suction pressure than the dust collector, but less CFM than this one, and less pressure than this one. So it's kind of partway between a shop vac and a dust collector. And what I've got here right now is actually, I tried bypassing the cyclone, so I'm just sucking straight into the filter box here, no cyclone. And bypassing the cyclone makes about as much difference as taking off one of these 10-foot long, 2.5 inch hoses. So the cyclone offers considerable air resistance for dust collectors, but compared to what a shop vac deals with, it's much less air resistance, say, than just one of these hoses here. So sucking through a cyclone for a shop vac is a relatively small penalty, but for a dust collector like this, it actually cuts the no hose airflow in half because it just has a lot of air resistance. And with the relatively low pressure of this dust collector, you really don't want to put a cyclone in line because that will really cut down on the airflow. So I hope you found these experiments useful. I certainly always enjoy them. Just now I have to put all my dust collection stuff back together.